E-E-Y. Do I have another one of those? E-E-Y. So I'm going to get, because that's not distinguishable. And then these two are the same. So how many distinguishable ways are there? 3. There were 6 ways to arrange them, but because I had the same thing in there, it made some of them come out the same. So do we want to have to list all these out and cross out the ones that are the same? No, we have a nice little formula to take care of this. And the key word is distinguishable. When you see that word in a problem, think, okay, I've got a formula for this, so I don't have to list them all out. Here's your formula. Distinguishable permutations. You talk about distinguishable permutations when some of your objects are identical. Okay, the formula looks like this. It's n factorial, and I'll tell you what the letters are, over r1 factorial, r2 factorial, r3 factorial, dot, dot, dot. Okay, so what do you think n represents in this formula? Total number of objects. Okay, what do you think the r's in the bottom represent? The repeat. So r1 would be the number of objects that are the same. Like in the last one I had 2 e's. So the number of, what do I want to say? Because we can have more than, we're going to in a minute, number of objects that repeat of one kind. Oh, God, that was a horrible sentence. R2 is the same thing but of another kind. The number of repeats of another element. That'll make sense when we do our next example. That's why I can't phrase that any better. Dot, 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 because this can keep going on. That bottom can grow. How many distinguishable ways can you arrange the letters in Mississippi? Distinguishable arrangement. M-I-S-S-I-S-S-I-P-P. I thought it looked a little short. M-I-S-S-I-S-S-I-P-P-I. Thank you.
I feel like that'd be really hard if you lived in the state of Mississippi. And when you're
Look at me, I've got to sing the song to do it. Distinguishable arrangement. There's your key word to tell you distinguishable. Oh yeah, I've got some of those objects are the same. I've got a formula I've got to follow. So, what's first? Total number of letters. How many letters? What's my n? 11. So it's 11 factorial. What could R1 represent? The I's. Let's go with the I's. How many I's are there? I'll just, R1 is the letter I. And how many do we have? 4. So that's a what's that going to be in my formula? 4 factorial. Because there are 4 i's. What would R2 be? The s's. How many of those are there? 4 again, so that's another 4 factorial. Anything else repeats in there? P's. So we've got an R3, we've got a third element that repeats. That's the P. How many P's are there? 2. Any other R's? No, we had I's that repeated, S's and P's, that's it.
Do they have to be in, like, descending order? Like
Nope, because those are multiplied, and when we multiply, it doesn't matter what order I multiply in. So now it's a calculator problem, and the only thing you got, what am I going to need if I type this all in one line? Parentheses are on the denominator, or you will get it wrong. So this dividing by the R factorial eliminates those repeat ones that we found when we listed them all out with a simple one.
Where do all of those kids go every day? Library.
Library or a lab, usually a lab. I don't know.
They really look at
Every day?
Maybe they're working on paper.
Well, it's usually different stuff, like yesterday was super hard grade.
Hey, that was just like freshman. What did you come up with?
34,650.
Okay. Slap one more of these. Oh God, no. Not even close. Yesterday was your easy day. Today's your not so easy day. We will. I'll stop at 10 to.
And then no home.
Oh yes, you got lots of homework today. 'Cause we had an easy day yesterday. Should have 5 day yesterday.
I would have rather had the harder day
Taking a test yesterday, it wasn't any easier.
You're in charge of planting 23s along a nice in-town street. Okay, go to the lab. You're gonna plant 20 trees along a street. You've got 6 oak trees, 9 maples, and 5 popple. I don't know how to spell popple. I don't know. 6 oaks, 9 maples, 5 pops.
Can I change it to something like birch?
Birch. There we go. I can spell birch. 5 birch. How many distinguishable ways do you have to plant them along the street? How many distinguishable arrangements? What do I mean by distinguishable arrangements? Different orders of oaks, maples, birch. So, there's your key word. I've got some objects that are the same, so when I switch 2 oaks out in the same spot, that's not distinguishable. So, what's our formula going to be? 20 factorial, total number of objects, total trees, divide by repeats. There it is. Easy when it's right here. Just talked about distinguishable, I give you a distinguishable. Very easy to know what to do. How many you got? Oh. 520? Well, that's a lot. A lot of variety there. Okay, moving on to combinations. Ashley, you good? Not quite?
Yes.
Good. Okay, combinations. This is our last big idea. Okay. Combinations. Okay, there is only one way to do these, and it's with the NCR button. And this is when the order you're putting things in doesn't matter, it's how many different groups you can create. So order doesn't matter. we're gonna count, it counts the number of different groups you can make with n objects of size r. That's our NCR button. What's that?
I feel like we did this one this year.
Oh, no, it wasn't all the way to last year. Over a year ago. Paige already did this stuff like before Christmas, so it's been over a year since you've seen it. Okay, what do I got here? Let's see. Let's say you've got 16 songs on your playlist, and you only have time for 3.
This happens in a lot of
Yeah.
big
How many different options do you have?
By the time you figure it out, you don't have to use it.
I know. Different options. So, do I care what, or am I asking what order I can put these in? No, I just want to pick a group of 3. So, how would you get this answer? 16, choosing, you think of C as a choosing 3 of them. Oh, thank you. I'll take that.
Real combination instead of options, is that cool?
Yeah, that's fine. And what was this one? 516? 560. 560. Let's go back to our softball team again. Of 15 players. And you have to pick 2 co-captains. How many options do you have? Okay, how is this different than the other one where I said we were picking a captain and an equipment manager? What's that? They were 2 different things. The captain was way different than the equipment manager. So if Bridget was captain and Anna was equipment manager, that's different if I switch them. Make Anna the captain and Bridget the equipment. That's why I had to count those as different outcomes. But here, co-captain, if Bridget's a co-captain and Anna's a co-captain, if I switch them around, that's the same set of co-captains. So does the order matter here? No, these are the same thing, so it's just choosing a set of 2 people from these 15. So don't think of this as an NPR, this is an NCR. These are the ones that people get confused on. So this would be 15